Hey guys, I'm Volen and welcome back to Advent of Code. It has been almost a month right now. But I'm finally going to do day 16. I cannot leave things unfinished, and these two 1-stars, I will try to go over them again in the next month or something, or the next months. I'll try to finish it by the end of this year. But anyway, day 16. I have not really looked at any content yet of this, so I have no idea what the other challenges are. Reindeer Maze. It's time again for the Reindeer Olympics. This year the big event is the Reindeer Maze, where the reindeer compete for the lowest score. You and the historians arrive to search for the chief right as the event is about to start. It won't hurt to watch a little, right? The reindeer start on the start tile marked S, facing east, and need to reach the end tile marked E. They can move forward one tile at a time, increasing their score by 1 point, but never into a wall, hashtag. They can also rotate clockwise or counterclockwise 90 degrees at a time, increasing their score by 1000 points. Wow. To figure out the best place to sit, you start by grabbing a map, your puzzle input, from a nearby kiosk. For example, okay, so this is probably the test data, and let's save that, okay. There are many paths through this maze, but taking any of the best paths would incur a score of only 7036. This can be achieved by taking a total of 36 steps forward and turning 90 degrees, or a total of 7 times. Note that the path shown above includes one 90-degree turn as the very first move, rotating the reindeer from facing east to facing north. Okay, yeah, that's also something we need to take in mind then. Analyze your map carefully. What is the lowest score a reindeer could possibly get? To begin, get your puzzle inputs. I'll take a minute to figure things out and to make a plan. See you then. Okay, so I don't think it will be too difficult. So I will have one value, and after every run of reaching the end, I will save that value. And I will just make the function iterate over itself. And if it goes at any moment over that amount of, over the total amount that we have saved already, then we just terminate that run and we go to the next one. That way we save a little bit on performance, and I think that could be good. I think this could work. So yeah, let's try. Okay, so there were quite a few distractions, so I could not work on this like in a row. So basically what I have is I get the map. I set the lowest value on 0, and then I run follow path with instead of a class called move with the map. So the move class is very simple. It can turn right, can turn left, step forward. I need to create my own duplicate function because apparently that does not work for in-class classes, for like subclasses of a script. So yeah, that was a nice discovery. So when you initialize a move class, you need points, position, a direction, and then we just go over this entire thing. First we check if the amount of points in a move is bigger than the lowest value. If that's the case, then we return, because the total amount will be higher anyway, so we don't really need to wait until we get the end result. Then we get the surrounding, and the surrounding, we basically create a string of 3 characters. So we have left, front, and right. For that, we just get the next character of that map. For the get character, it's just a very simple apos.y, apos.x to get the line and which line and which position in that line, in that string. Then we check for an E. If there is an E, we need to step forward to have the 1 extra point that it needs to get to the E itself. And if the first, so 0, 1, 2, if the middle character of the surrounding is not an E, then we also need to turn left or right. If you turn left or right, it does not matter which one. I choose left because in the end, what it does is just change direction and add points and step forward. So we don't really need that anyway. So yeah, that's why I do that. Then we create an array of moves. I guess I could just skip the whole like creating a move thing and just call. I don't really need this, so we don't need to save all the moves. So I can do this, this, this. We don't need this one anymore. We don't need to append and this will be a move. So when we run this, we should get a result of 7036. If we go into our Advent of Code, this is 7036. I won't test the other result, I'll just directly take my normal input. Normally this should work, so let's do this. So what I noticed with test data, with the second test data, it is slightly bigger. We do get the correct amount of numbers, so somewhere it's going wrong in the full map. I think we're just at the limit of how many times a script can run. How about we do this? But that also means my script is probably not very well optimized. Okay, that is something. Right now the problem is that follow path is getting called too many times, so we need to be able to lower this amount. Okay, so I did do some changes. So first of all, I created a new function to just get the possible points for an early break. I'll quickly remove this line. And basically what it does is, if it's not on the same Y position, we add 1000 because we will have to turn at least one time. If it's not on the same X location, then it will also need to turn at least one time. So and then again, plus 1000. And then for all the positions in between that we still need to do, we add one. So this should help with the stack overflow thing. And then we also have for forwards, I added a while loop. Let's also quickly clean this one up. So we step forward once and then we just copy the move. I think that's correct. We don't actually need to do this. We should just do this and then L new move, and then we step forward. And then we just keep checking if the surrounding, if the first one in front of it is a dot, and if there's only one dot. If there's none in front of us, then we need to go left or right. Or it can also be that we are at a dead end. So yeah, we do this. Okay, let's test it on the real data. Hopefully this won't take as long and no stack overflow. So we can double it. So let's hope that works. Not really have any idea what's happening when I do that, so I should really get a print statement in here. We print the lowest value, and that way we can at least see whereabouts we are in the code. A lot of too high. I think we will get the correct result in the end, but yeah. I think it's obvious that my code is not the cleanest right now. And not the most performant. Okay, so I've been doing kind of a little bit of math and trying to find new things, but I think this is the part that really helps a lot. So I'm taking in mind all the dead ends so I don't go through all the dead ends. So dead end, possible dead end. Basically, I follow the path. Well, first follow the path. If the position is in dead ends, then we just return. I just see like this won't work. Like I ran it, I got this number, but this will not be correct. I'll still test it, but that's not the right answer. I just thought of a much better thing to do. So instead of checking for the dead ends, I should check like all the positions that I've been at. If the value is lower. So basically, we create a dictionary with all the positions, and for every position we set the amount of points that it took to get to that position before. If it's lower, we continue. If it's higher, we stop. So I'll quickly implement this. I think this will be the performance thing that we need. Okay, so I did implement this whole system, basically I added these lines and removed the rest of the L moved and such. So this, it appears to work, so let's try with the normal data. I think I got it. I think I made a good performance thing. Okay, so let's see if it's actually correct or not. Return to day 16 and submit. That's the right answer. You are one gold star closer to finding chief historian. So continue to part 2. Now that you know what the best paths look like, you can figure out the best spot to sit. Every non-wall tile, S dot or E, is equipped with places to sit along the edges of the tile. While determining which of these tiles will be the best spot to sit depends on a whole bunch of factors. How comfortable the seats are, how far the bathrooms are, whether there's a pillar blocking your view, etc. The most important factor is whether the tile is on one of the best paths through the maze. If you sit somewhere else, you'd miss all the action. So you'll need to determine which tiles are part of any best paths through the maze, including the S and E tiles. In the first example, there are 45 tiles marked O that are part of at least one of the various best paths through the maze. Okay. In the second example, there are 64 tiles that are part of at least of the best paths. Okay, so so we need to save all the maps which have the equal amount of times like goes to go there. Analyze your map further. How many tiles are part of at least one of the best paths through the maze? So what we need to do is var saved maps packed string arrays. And this will be kind of easy, so I guess I can comment this one out. If lowest value is the same as a move dot points, then we start saving the maps. And else saved maps is just a new array with a map, so we also don't miss the first one that appears. So this should normally print 64. Okay, so what I'm thinking is this function is stopping them kind of early, so we do have the caching thing, so I don't think that is no longer needed. So if we go into get surrounding, that's fine. Get possible points, we just remove this function. Okay, and if I print this now, 64, okay, and let's take our normal data. But I think we got it now. This should work. 115 500. 115 500, and we have 656 spots. So let's take this. Let's go in here, submit, and this should... The answer is too low. Wait, how can it be too low? How about I just add like this? Let's see, maybe this will make it last, like take a little bit longer, but well, if this does not work, I'm giving up. Okay, so part 1 worked. We do get a higher number now. Is this the most performance? Nope. We got a higher number, so let's hope. That's the right answer. You are 1 gold star closer to finding the chief historian. So what I think what's happening is we were like skipping too early if it was the exact same value, or like close enough that it would not matter too much. So the way that we're setting our points was probably a little bit too early. I don't know when I will do the next one. I'll see. And when I will fix the other ones, I'll just take my time, work on other videos as well, work on the other YouTube channels as well, work on GoZen, and every now and then I will keep doing this one. And I hope for next December I'll be able to do it daily again and hopefully stay at it. Let's see how good I'm getting at these, because else, yeah, let's see. Anyway, thanks for watching. A big thank you to my Ko-fi supporters. GoZen is getting usable. Just by the way, like you can edit videos in GoZen now. We entered alpha and development is going great. So yeah, thanks for watching and I'll see you all in the next one. Bye bye.